Good day. So welcome back to the video presentation for lesson 1.2. So now we are in square of a binomial. Okay, so how we're going to get the product of square of a binomial. So let's see this in example, no? So x plus y, the quantity of x plus y squared. So how we're going to get the product of this one? First, you're just going to get the square of the first term. So we have your x squared plus twice the product of the first term and the second term. So you have your 2xy. And then lastly is we're going to get the square of the last term. So we have your y squared. Okay, so example. So we have here the quantity of 2a plus 5b squared. So again, we will get the square of the first term. So nakay 2a quantity squared plus twice of the product of the first and the second. So you have your 2 times 2a times 5b and then square of the last term. So you have here 2a squared, you have your 4a squared, and then 2 times 2a times 5b, you have your 20ab, and then you have here the square of 5b, you have your 25b squared. So this is now the product, or this is now the answer when we're going to square 2a plus 5b. So by the way, class, you may also answer this because the 2a plus 5b squared, it's just the same as 2a plus 5b times 2a plus 5b. So they're just the same. So you may follow the FOIL method and then you will have the same answers. So for example, no, 2a times 2a, you have your 4a squared. And then 2a times 5b, you have here 10ab. And then 5b times 2a, you have here again 10ab. And then 5b times 5b, you have here 25b squared. So, getting the sum of these two, because like terms ang middle terms, so 10ab plus 10ab, it's 20ab, so it's just the same as this. So, this method is shortcut of this method, the FOIL method. And we can add this, all this applicable for the square of a binomial. Okay, so next we have your 3x minus 4y squared. So again, we're going to square the first term. So you have 3x squared plus twice the product of the first term and the second term. So our second term is negative 4y. So you have here 2 times 3x times negative 4y. And then last, we are going to get the square of the last term, which is negative 4y. So now 3x squared, you have here 3x quantity squared, you have your 9x squared, and then you are getting the product of these 3. So 2 times 3x, it's 6x plus negative 4y, it's negative 24xy, and then the square of negative 4y, you have here 16y squared. So take note that this is just equal to negative 4 squared times y squared. So negative 4 squared, it's 16, and then y squared, it's y squared. Okay, so same thing follows with number 3. So 2x plus 7y quantity squared. So what is the product? So you have your square of the first term, you have your 2x quantity squared plus twice the product of the first and the second. So you have your 2 times 2x plus 7y. And then next, you're going to square the last term. So you have your 7y quantity squared. So now getting now our final answer. 2x quantity squared, you have your 4x squared, and then 2 times 2x times 7y, it's 28xy, and then 7y quantity squared, it's 49y squared. Okay. So number 4, same process. No, again, we're going to get the square of the first term. You have your a squared, getting the twice of the product of the first and the second. Our second term is negative 3. So you have 2 times a times negative 3, and then squaring the last term or the second term, you have negative 3 squared. So now a squared, 2 times a times negative 3, it's negative 6a, and then negative 3 squared, it's 9. So this is it. So this is how we're going to get the product when you're going to square a binomial. Now, how about if, for example, this is the given a squared minus 6a plus 9. So how are we going to get the factors? So the factors are this one, a minus 3, a minus 3, or just simply a minus 3 squared. So again, we're now in the reverse process. Given, for example, the product, so given this one, for example, given this one, and then given this one, so how are we going to obtain the factors? How are we going to get this one, and this one? So here is how we're going to do that. By the way, when you're going to get the square of a binomial, the result is a perfect square trinomial. So again, squaring a binomial will give us a perfect square trinomial. So perfect square trinomial, or simply PST. Okay, so we have now two terms. We have general quadratic trinomial and the perfect square trinomial. So again, our GQT, unsa ganin ni siya? This is the product when we're going to multiply two binomials having similar corresponding terms. And the process in factoring GQT is by trial and error method, or we have here the TAE method. Okay, so now, how are we going to factor PST? So take note that PST, it means it's trinomial. So meaning, when we have a trinomial, we have to identify first if it is a PST or GQT. Because if it is a GQT, then our method will be trial and error method. Now, if it is a PST, then it's our life, or our solution will be easier compared sa GQT, because we don't need to try combinations. Okay, so now, given a trinomial, how will we know if it is a PST or not? So, we can say that it is a perfect square trinomial if it satisfies two conditions. Okay, we have here two conditions to satisfy. So first condition is the first and the third terms must be perfect squares. So that is the first condition. Next, the middle term must be twice the product of the positive square roots of the first term and the third terms. Okay, so that is condition for PST. So for example, this one, x squared minus 2xy plus y squared and x squared plus 2xy plus y squared. So how will we know that if this is a PST or not? Take note that this consists of three terms. So kung three terms saya, so we have two choices. Either it's a GQT, which is, we've discussed this in a previous video, and we have your PST. So if it is a GQT, then again, our process will be trial and error method. Now for PST, we have technique such that we're going to try some combinations. Now, how will we know if it's a PST? Again, the first term and the last term must be a perfect square. So when you say perfect square, we should express it as quantity squared. Okay. For example, now 4 is a perfect square because we can express 4 as quantity squared. You have your 2 squared. 9 is a perfect square because we can express 9 as quantity squared. You have your 3 squared. So again, for us to say that a trinomial is PST, it should satisfy the two conditions. First condition, the first and the last terms must be perfect square. Next condition, the middle term must be twice the product of the positive square roots of the first and the third term. So in here, for example, what is the square root of x squared? So we have your plus or minus x, diba? But we will take only the positive square root. And then the square root of the last term, or the third term, you have your plus or minus y. Getting the positive square root, you have your x, and then you have your y. Ingon siya, the middle term should be twice the product of the positive square root of the first term and the second term, which is x and y respectively. So getting the product, it's 2xy. So you have your negative 2xy and you have your 2xy. So meaning to say that these two expressions here are PST, perfect square trinomials. Ma'am, how about this negative sign here? So don't worry, because this sign here will be our determinants in whatever sign that we're going to use in our factors. Okay, so for instance, we have here, how are we going to factor, no? I forgot class. How are we going to factor this one? So again, we've discussed na how to determine that if a trinomial is a PST or not. Now, how we're going to factor a PST? So to factor a PST, just get the positive square root of the first term and the last term. So we have your x and y, and then you're going to follow the sign of the middle term. So we have your negative man here, so we have your negative, and then raise it to square. So that's it. So for the second expression, this is positive, so meaning we're going to have your positive. Okay, so for example, let's go back to here. So a squared minus 6a plus 9. So again, I've told you before that the product of a square of a binomial is a perfect square trinomial. So ato i-check no kung PSD ba gud siya if it really satisfies the two conditions that I've mentioned before. So your first term must be perfect square. So a squared, we can express a squared as a quantity squared. So indeed, a squared is a perfect square. 9, we can express 9 as 3 squared. Okay, so now getting the square root, so again, it satisfies the first condition. Now getting the square root of the first term and the second term. So in getting the square root, class, we just simply cancel this out. In a way, we just need the positive square root, no? So we have your a and then 3. You have to check, class, that your middle term should be twice of the product of the positive square root of the first term and the last term. So in this case, you have your 2 times a times 3, which is equal to 6a. Again, do not mind the negative sign because this will give us the idea, or this will be our guide onto what sign we're going to have in our factors. So to get the factors, just get the square root, positive square root of the first and the last terms. So the positive square root of a squared is a, and then the positive square root of 9 is 3, and then follow the sign of the middle term, you have your minus, and then raise to 2. So that's it. So let's have this one, no? So another example, 4x squared minus 12xy plus 9y squared. So you have to check first if it is really a PST, because if not, then we have to follow the trial and error method for GQT. Because if it is not a PST, then it is a GQT. Okay, so first condition, your first term and your last term must be a perfect square. 4x squared, we can write 4x squared, diba, as 2x. And we can write 9y squared as 3y squared. So meaning the first and the last terms are perfect squares. So what's left is we should see that our middle term should be twice the square root of the first term and the last term, the positive square root. What is the square root of 2x quantity squared? You just cancel out. Anyway, we just need the positive square root. So you have your 2x and then you have your 3y, or just simply get the base, class. When you have here, for example, 2x squared, the square root of 2x squared will be just the base. Just the base. So you have 2 times 2x times 3y. So getting the product, it's 12xy. So indeed, it's a perfect square trinomial. Now, what are the factors? So just the base, just get the base, 2x, and then follow the sign, negative, and then base, 3y, and then raise it to 2. You have this one. Okay, I hope you can follow. So another example. So 9a squared plus 24ab plus 16b squared. So how are we going to get the product? I mean, how are we going to get the factors? So first, we have to check if this one is indeed a PST. So first term, we can express 9a squared as 3a quantity squared, and also we can express 16b squared as 4b quantity squared. Now you have to check the middle term. It should be twice the square root of the first term and the last term. So you may not get the square root, class. You just get the base, just the base. So you have your 3a as our base, and then get the base. So it's just 4b. Getting the product, 2 times 3a times 4b, it is indeed 24ab. So meaning this is a PST. So what is then the factors? So just the base again, 3a, and then you have your 4b, and then follow the sign plus. So you have your 3a plus 4b squared. Okay. Another example. So, mom, is this a trinomial, we have here a lot of terms. So yes, this one is a trinomial. Considering this one as our first term, okay, this one is our second term, and this one is our third term. Okay, so just like what we did sa previous video, we're going to let this one. Take note, we have your 2a minus 3b, and then you have your 2a minus 3b. So we're going to reduce this into one variable lang. We can let this as, let 2a minus 3b be your, let's say, x. So we have here, this one is our x now, raised to 2. So you have here x squared minus 8x plus 16. You follow? We just substitute 2a, x to 2a minus 3b. And then we're going to determine, is this, okay, I'm just going to write it here. Now, next thing that we're going to do is we will determine if this one is a PST or just a JQT. So we have to get, we have to determine if the first term and the last term is a perfect square. So you have your quantity squared. We can express x squared as simply x quantity squared, and also 16 as 4 squared. So next, the middle term, it should be twice the square root of the first term, just get the base, and the last term, just get the base. So 2 times x times 4, it's 8x. So indeed, this one is a PST. So what are then the factors? So just get the base, we have your x, follow the sign, minus, and then get the base, we have your 4, and then raise to 2. Take note that this one is not our equation, our expression, because our x is 2a minus 3b. So what we're going to do is we're going to substitute again the value of the original 2a minus 3b to x. So we have here, okay, we have this one, x as 2a minus 3b, and then minus 4 raised to 2. Okay, so I hope that you've learned something. I hope that it's clear. Okay, so next we will have here the product of the sum and difference of the same binomials. So we have your two binomials and they just differ with the sign. So what we're going to do is we're just going to get the square of the first term of the two binomials minus the square of the second term of the two binomials. So you have your a squared minus b squared, or you can also have the full method class. You have your a plus b minus a times a minus b. Full method, you have this, a times a, you have a squared. A times negative b, it's negative ab. A times b times a, it's ab. And then b times negative b squared, it's negative b squared. And then subtract the middle terms because they are like terms, and negative a plus ab, it's 0. So what's left is a squared minus b squared. So that's it. So you may have the file method, or you just have the shortcut. Just square the first minus square of the second. So for instance, example 1, 2x plus 3y times 2x minus 3y. So they just differ with a sign. They're exactly the same. Our binomials are exactly the same except for the sign. So what we're going to do is just get the square of the first term, square of 2x minus square of second term 3y. So simplify. So 2x quantity squared, it's 4x squared, and then 3y quantity squared, it's 9y squared. So this will be your final answer. Okay, so by the way, when you get the product of the sum and difference of the same binomials, the answer or the product is difference of 2 squares. So we have no terms, no, we have GQT, we have PST, and now we have difference of 2 squares. Again, the product of the sum and difference of the same binomials is called as difference of 2 squares. Okay, so kanisiya, this is called as difference of 2 squares because this one is a product of the sum and difference of the same binomials. Now, sorry, this should be a y squared. So 7x plus 5y times 7x minus 5y. Again, they just differ with the sign. So what we're going to do is we're just going to square the first term minus the square of the last term. So you have your 7x quantity squared minus 5y squared quantity squared. So getting now the square, you have here 49x squared, and then this one, okay, this is just 5 squared. Okay, you have your 5 squared square. Applying your laws of exponents. So 5 squared is 25, and then y squared square, it's y raised to 4. So this will be your final answer. So same process for number 3 and number 4. So they're just having here, they're exactly the same except for the sign. Okay, by the way, this should be squared. It should be raised to 5. Square raised to 5. Sorry. So for number 3, okay, get the square of the first term. You have your 3x quantity squared minus square of the last term. You have your 4y quantity squared. Simplifying, you have your 9x squared, and then you have your 16y squared. So this will be your final answer. So now for number 4, 8r squared plus 3s raised to 5 times 3r squared minus 3s raised to 5. So what is its product? So same, we're going to get the square of the first term, 8r squared square, and then minus the square of the last term, 3s squared, 3s raised to 5 squared. So simplifying this, again, same with number 2, with this one. It's just the same as 8 squared r squared square, so which is just equal to 64. 8 squared is 64, and then power of a power, r raised to 4. So you have this. Minus this one, the same process. 3 squared times s raised to 5 squared. So 3 squared is 9, and then power of a power, multiply the two exponents, so 5 times 2, it's 10. So meaning the product of 8r squared plus 3s raised to 5 times 3r squared minus 3s raised to 5 is equal to 64r raised to 4 minus 9s raised to 10. Okay, so now, in reverse, what if given is siya, ma'am? Given, this one is given, and then we are asked to find the factors. So given is siya, these 4 are given, and then we are asked to find the corresponding factors. So what will be our process? Okay, so what we're going to do is just get the square root of our terms, and then you have to put it in our factors, and then our sign will be alternate. We have your plus or minus. Okay, so for example, 4x squared minus 9y squared. So you are going to get the square root of this 4x squared and then 9y squared. Or simply, class, just like what we did with the PST, no? Just express this one as quantity squared and then get the base. So 4x squared, we can write 4x squared as simply 2x. 9y squared as simply 3y. So how about the factors? Just get the bases. So 2x, 3y. 2x, 3y, 2x, 3y, and then the sign is alternate. We have your plus or minus. Or pwede pud ka minus plus. It doesn't matter as long as the signs are different. Okay, so how about number 2? So this one, a plus 3b quantity squared minus 4. So if you're still in doubt, no, if you can still have the shortcut, you may have a step-by-step process. So you may let, x to be a plus 3b, and then we are going to substitute x to a plus 3b here. So you have x squared minus 4. So we can write x squared as x quantity squared, and we can write 4 as 2 quantity squared. So what are then the factors? We have here 2 factors. Just get the bases. So x, and then alternate ang sign. I mean, you have your 2, and then alternate ang sign, plus or minus. Again, you may have your minus or plus. Okay. So just a reminder, class, this technique is only applicable for difference of 2 squares. So naakay 2 squares and then minus ang operation. Okay, so we're not yet done here. Our factor is x plus 2, no, times x minus 2. But take note that we let our x to be a plus 3b. So you have to return to the original expression. So substitute a plus 3b to our x. So this now our answer. This is our x plus 2, x plus 2, and then we have here x minus 2. So, yan. Next, this one. X raised to 6 minus y plus 0 raised to 2. Mom, you've said that it is difference of two squares. So what you're going to do, class, is you're just going to express x raised to 6 as quantity squared. Quantity squared. So to do this, we are going to divide 6 by 2. So 6 divided by 2, it's 3. So it means that x raised to 6 is equal to 3 x cubed raised to 2, because when you're going to get the product, it's equal to x raised to 6. It's equal to 6. The exponent is equal to 6. So this is now a difference of two squares. So what we're going to do is just get the base of your squares. So x cubed, x cubed, x cubed, and then this one, y plus z, because it's already in quantity squared. So y plus z, y plus z, and then our operation is plus and minus. Okay. Next, how about this? Mom, how are we going to factor this out? So same thing with number 3 with x raised to 6. We need to rewrite this one as quantity raised to 2. So we can write a raised to 8 as a divide 8 by 2, because we are aiming for 2 na exponent, no? So dapat ang ibang exponent nasa baba. So 8 divided by 2, it's 4. So simplifying this, 4 times 2, diba, it's 8. So they're just the same. And then we have your minus, okay, sorry. Okay, minus b raised to 4 squared, because they're just the same, 8. So how are we going to get the factors? Just get the bases. So a raised to 4, a raised to 4, b raised to 4, b raised to 4, and then our sign must be alternate plus or minus. Now, we can still express the second factor a raised to 4 minus b raised to 4 as a difference of two squares, right? Because we can rewrite this one as a squared square minus b squared square. So this still satisfies the difference of two squares. So what we're going to do is factor out this. So a squared, a squared, a squared, and then b squared, b squared, b squared, and then alternate ang sign. So just bring down this, because what happened to the next line is we just factored out this one, which is just this one. Okay. So next, this is now still a difference of two squares. So what we're going to do this, okay, you have to copy the first two factors, copy this and copy this. We have this one, and then this two are the factors of this one. And we can no longer factor this. So this will be our final answer. By the way, we cannot apply the same method as to how we're going to factor this one, because we only have your difference, we don't have sum. So we will leave it this way because we can no longer factor this one. Okay, so this will be our final answer. So I think that's all for part 3. So part 4, we will have here the cube of a binomial. So I hope that you've learned something. So if you have clarifications, so don't forget to just comment or post there in our group, or you can drop me a message. Okay, so that's all for this video. I hope you've learned something. Thank you. Happy learning and God bless.